All right. Welcome, everyone. We are in review session tonight. So if you want to just start working on things, that's fine, but I'll open it up to if anyone has questions. Um, and primarily, I think not I don't think, I know the best way to know what's on the test is to look at our exam one review. The ones I have highlighted are close to, again, they are not exactly what the questions are going to be, but if you understand those questions, those are in some cases very similar to how they're asked, but they're those content. So I chose basically going through this. This could almost be the ones at least I've highlighted could be a version A and a version or a version B. They're close enough that way so that you will know what's on there. Again, there's 6 questions that are multiple choice. So I'm not saying which one of them are, but those you approach a little differently, maybe, because all you have to do is identify the right answer, right? So sometimes you can plug in the answers, see what works, but there's ways of working a multiple choice that's different than an open answer. There are 3 that are true false, but that's good. There's a bunch of true false here, so getting practice with going through true false questions, because I hate true false questions because I always overthink them, and I get the gut feeling to do the right thing, but they're trying to trick me, and then I trick myself. So just go through them, see how they work, and they are pretty straightforward. And then there are 8, 9, 10, 11. There's 4 that are sort of open answer where they just say, find this derivative or find this limit and show your work. Now, it doesn't mean you have to put like prove it or do extensive work, but show, so that you know how to get to a limit. So just show something along the way. You don't just write down an answer, but show it. Um, and these are the highlighted ones. And again, these ones I highlighted 3 of them just because there'll be, probably only one. Well, not there'll be one question like these, but I wanted you to look at the various forms, and that's why you want to get through as much of these as you can, because sometimes there's 2 or 3 different ways it could be asked, and so if you do all of this, you'll have all of that down. Um, and again, it's not that the non-highlighted ones are unimportant, but I would focus first on getting through the highlighted ones. And that would give you also a feel for about the length of the test. It's got about that many questions. And then go back and practice with the other ones. Remember, there's also so where I got this from is Canvas, the 2223 exam review. So there's an unadulterated one up here, the review. There's the answer key here, so that's been there for a while. This is the highlighted one, so that's the one I showed. It's really the same thing, except it's got highlights. And then there's a recording of the session we did on Tuesday. I don't know, I can't remember what we did, but whatever we did, it's there. We talked about a few things. I showed, and remember, I did show you one. There'll be one where it allows you to find the derivative, and it's 2, what do they call those things? Binomials. That you have to FOIL it out, because otherwise you would need to use the product rule, and we're not going to go there. So just FOIL it out first, and then just take its derivative like we've been doing. And remember, pretty much all we know how to do right now is take an exponent, bring it in front and multiply, subtract 1 from the exponent. But know how to do radicals, fractional exponents, 1/2, 1/3. Know what happens with negative exponents, or if it's down in the denominator, bring it up, make it negative. But that's basically, as far as the derivative, that's all that will be on this test. So any questions? Nope. Okay, I can go home now. No. Sure. Oops, where is it's this one that I want. Okay. Where did it go? Oh. Oh, I want to do it. So I want to open this one. I think it's what I was doing. Yeah. So there is one we've got marked. Let's see. Yeah, so this one, number 4, uh, again, similar to how it might be given in the exam, they'll give you a cost function, they'll give you a revenue function. There we go. Let's go with this one. So here we've got a cost function. Here's a revenue function. And then we're asked to write a profit function from that. So the idea is that we're going to take the revenue function, we're going to subtract the cost function, and that will give us the profit function, right? And so then we replace those letters. That's kind of always the way it is. So revenue is simply 7x. Cost is this longer thing. And you can do it in multiple ways. You can write it and put a parentheses, but what you have to make sure is that that negative, that subtraction, is going to distribute to each of the terms. I like to do that in advance, save myself. So this 150 is going to be negative 150, right? I'm kind of distributing the negative as I go. This plus 0.01 is going to be negative 0.1x. And the last term, oops, I put a plus. I should just, that's going to be negative as well. So just make sure you distribute that negative all the way through. X squared. And then we just need to combine like terms. So there's a 7x and there's a negative 0.1x. So that gives us, is that 6.9x? Is that positive 6.9x? And we don't have to get it in any special order or anything. We could leave it as is. And that's our P of X. That's our profit function. So again, know how to do that. Calculate P of 100. So then we plug 100 in for X. We could do that. Write a marginal profit function. So since we've got the profit function, we just take its derivative. So that's just the key word here. So you see, it wasn't really too much new, but just an application. P prime of X is what we need. So P prime of X, remember there is a 1 up here. So we take 1 times 6.9, that's 6.9. We're going to subtract 1 from the exponent. And I've been working with some of you. This one is actually kind of, it's sort of easy because it disappears, but it's also one of those that can cause you to, is that X still, what happens to the X, right? X to the 0 is just 1. So that's 6.9 times 1, the X is gone, right? And the difference between that and a constant, well, we'll get to see that here. So that's that first part. What's the derivative of negative 150? 0. It's a constant. I'm going to actually just write that in just to emphasize the differences. Subtract 0 or plus it, whatever you want to do, but just know that the constant is 0. And then the last part, we bring the 2 down and multiply. So it's going to be 0.004, and this is negative. And then we subtract 1 from it. 2 minus 1 is 1. And that's perfectly fine. If you even left it that way, you'd get full credit. If it was like open answer. If it's a multiple choice, then you just have to, once you got it, choose the right setup. It might, they might reorganize it or something, but they won't do too much more than that. And you're not going to see anything more complicated than that. Because it's a constant. So remember, a constant is like y equals negative 150. It's a horizontal line. The slope of a horizontal line is 0. It's kind of always make that connection. So yeah, so this, if it were by itself, is the function really y equals negative 150. If you graph it, it's a horizontal line down here at 150, at negative 150. Horizontal lines, slope is 0. Okay, but that's kind of the one, just make sure you understand that part because it's easy to confuse. Sure. So if here's our revenue, and again, they could give, well, actually, this is the revenue function, right? So marginal revenue is simply take a derivative of this function. So this would be 7. Marginal cost, just take the cost function, take its derivative, that's marginal cost. So it's just, the marginal is just another word for take the derivative of that function. So they're going to give us, they'll either give us the original function, or in this case, they don't oftentimes give us a profit, but they give us the cost and the revenue. They give, and then we have to know to subtract them. Okay. And it is such that you could take the marginals first and then subtract the marginals. You end up the same because that's how it works. But one, it's very similar. Give us the profit function, give us the marginal profit. So you're combining cost and revenue. But yeah, you can do marginal cost, take that function, take its derivative, that's the marginal cost. Then calculate your marginal profit if you produced and sold 100 candles. So again, once we have this, all we have to do is put 100 into that function. And that's part of what you'll need to look at the test. Is they'll sometimes ask what's the value, and you know, if they wanted to know the profit like they did here, P of 100, that goes into the profit function. But if they want to know the marginal profit, that number goes into the marginal. So you're always in calculus. We're going to get two functions: the original function, and then the marginal, or the derivative, the marginal function, the slope function. And remember, the original function gives us a value, like how much profit. The marginal will give us the rate, whether it's increasing, decreasing, and by how much. But it's that how much if we sell one more. That's what that's going to give us. Is that good? I think they're not any harder. It's not like, okay, these are some simple ones and we're going to give you some hard ones. They're nothing different, nothing more serious than these. Seriously. Yes, sir. Oh, sure. Let's see. Let's get this stuff out. And I am recording this, aren't I? I think so. Yeah, looks like it. Okay. So say that again. So something like, yeah, so if our function is, I'll just do it down here. This one also is a tricky one. We want to rewrite it with a negative exponent. Sometimes people will take that 2, they'll take the 2x up, but the 2 is going to stay down here. So let's say this is f of x. So when we go to take its derivative, we want to rewrite this as bring the x up. So that's now going to be, instead of x to the positive 1 power, that'll be x to the negative 1. The 2 stays down there, so it's really, you could write it this way, or 1/2 times x to the minus 1. Okay, and then when we take its derivative, what do? This comes down in front, so we multiply first by this, so we're going to get a negative 1 x, or we could put it down on the 2, yeah, wherever we need a negative coming somewhere, the 2 just stays there, and then good, and then you're a step ahead, subtract 1 from the exponent. So now this is a little, because the exponent seems to be getting bigger, right? But it's just getting more negative, so that's what happens with negative. It gets, because we're always subtracting 1 to get the derivative. You know, and now the problem is this is, I think, a little too early. I would try to do this. I'd say, oh, I know, I just subtracted 1, but too often I'll end up with x over 0, and I'll just have 1/2 or something. I'll mess it up. But if I'd take this step and put the negative 1 exponent, I'm more likely to say, okay, oh yeah, you got this negative coming down. When I subtract 1, I get -2. So, you know, and oh, and then, and again, if it's an open answer, if it's right, it's going to be right. You can have it in multiple forms, but you might see if this was multiple choice, they might put it back down. So the final answer might be something like, they might have the minus out here, 2x squared, right? Because it goes back down now, it's positive again. So these answers here are equivalent. That one, same thing. Do some practice with some radicals, right? Because of fractions, sometimes those are what throw you off more. Yes, sir. You got it. That's a good one to do. Um, in fact, I'll show you. I think I may have shown you. If you've got a TI-84 calculator, of course, you're also going to want to know, because if it's an open answer, they're going to have you walk through the steps, so we'll do it that way. Let's see. And there's those slope of the tangent line. Um, Now, if they just ask for the slope of the tangent line, what do we need to get? Just the slope. But I'm going to go ahead. I could work this one and also get the equation of the tangent line. So that's what I would do. We'll go ahead and do that. So the thing to remember, slope. So the equation of a tangent line equation of any line is y equals mx plus b. Where does the m come from? M comes from the slope of the tangent line at that point. Okay, so x equals 1, so we're going to do it at x. So our slope will come, so we got to find the derivative, plug in 1, and that's going to be our slope, right? So getting back to algebra, then all we have to do is find the y-intercept. But to get the y-intercept, we need the slope and a point. So we have this x value, we need the y value that goes with it. So we're also going to need, to get y, which is the original function at 1. And notice how these look so similar. One has a prime, that's the slope. One doesn't have a prime, that's the y value. Okay, so it's just, in math, you have to look for little details. But a lot of what you do in business is just, some little notations. Is that okay? I mean, we're not done, but let's do that now. We could kind of go in any order. So kind of figure out what works best for you. Some people like to find the y value first because that's the function. Others like to get the derivative first. Which one would you like to do first? Since you, oh, good. That's what I like to do, but that's what I like isn't important. So, but yeah, that's the calculus part. So let's get the derivative. We'll just do it in general first. So 3 comes down, 3 times 5, 15. Subtract 1 from 3, x squared, right? And then the 2x, there's a 1 on that, so 1 times 2 is 2. Subtract 1 from 1, and you get 0, x is 0, which is 1. So that 2 is now by itself. It's become a constant, but it wasn't a constant before. And then the last one, 4, is a constant. It's 0. So you could do a plus 0 if you want. Otherwise, just it's gone. Okay, but know that difference between the 2x, when it takes its derivative, becomes 2. The 4, since it's a constant, becomes 0. So this is our derivative. And to find the slope at a particular point, we take that derivative at that value, at 1. Plug in the 1, so we get 15 times 1 squared plus 2. 1 squared is 1, times 15 is 15, plus 2 is 17. And you might want to say something like this is m, this is the slope, because you'll get numbers laying out here and you'll get mixed up. Which one's the y? Which one's the slope? However you need to do it. So that's our slope. So what I do, okay, so far, you do this and we've got half the answer, 17x plus b. All we got to do now is find the y-intercept. So you can use what's called the point slope formula. I don't, because that's one more thing to memorize, and I said no, I know another way. What I can do is if you give me the x and the y, I plug them in here and then solve for b, and then I rewrite it. If you like using the slope point, and so I know there's some of you probably do, but you're probably very comfortable with, go ahead. Most of you are probably like me and you're not real comfortable with it. So, but we can do it if you want to see it that way. So what do we need? We've got an x value, right? We know that x is 1. We need to know what y is, right, for the point. So we come back to the original function, and I'll change colors. And again, it's helpful to do that. Let's see, what is f of 1? So notice this is not the derivative, it's the function value. So it's going to be 5, 1 to the third, plus 2, 1, plus 4. Okay, so the constant, everything's there. The constant is not a derivative. So that's 5 plus 2 plus 4, so that's 7. That's 11. Did I get that right? 7 plus 4 is 11, right? Okay, so what we know is we've got a point that this line goes through, 1, 11. That'll allow us to find the y-intercept. So the y equals 11, 17, x is 1 plus b. So this gives us 11 equals 17 plus b. Subtract 17 from both sides. So we get that b is negative 6. Again, be careful. Especially on long days, I make all sorts of mistakes. And so one of the things, if you need to take a nap in the afternoon or something, make sure you're fresh. That's usually the best thing. Prepare beforehand. Someone was asking what I will do. I'm not on campus on Mondays, but I will make a point. Let me just make sure I don't have any other. I will come early on Tuesday. That's next week. That's February. Oh, wait. Well, if you really need, how about if I'll be here by 4? Let me put it that way. And my wife gets back she's been in Thailand for like a year and a half. I went and saw her in summer, but I didn't get to go back for spring break. So I told her I'd check in on her first day back. Is that okay? But if you really need me, so 4 o'clock, 5 o'clock, we got 2 hours if we need to. But just let me know, okay? But I'll be back. I'll be on my office by 4 o'clock, and I'll bring my keys because a couple of you know I forgot my keys, so I was sitting on the floor of my office or out in front of my office. But I'll bring my keys this time. Okay. So where are we? So we're not really done. We want to rewrite it. It's final answer is going to be y equals 17x minus 6, and that is the slope of the tangent line. Now, if you've got a TI 84 or 83, you could actually plug the original function in to to graphing it. You could graph it, and then if you go to second draw, or what is it? Yeah, to draw and then have it draw the tangent line. It will draw the tangent line, and it will give you the equation of the tangent line. But again, if this is which is fine if it's multiple choice, because all you got to do is pick it. But if it is an open answer, they're going to ask you to show how you got the slope of the, how you got it. So you'll want to be able to, take the derivative, plug in the number, get your slope. But sometimes if you got the answer, you can kind of fudge your work too. Do what you need to do, right? And so calculators are great for checking on things too. Did that help? Okay. And that's all there is to and again, we're not going to give you anything overly complicated, but take the derivative, plug in the value, that gives you your slope. Y equals mx, you've got half your answer. All you need is an x and y coordinate. And from there, it's not calculus, it's algebra. But that's the problem is it's kind of like your mind is expecting to be doing calculus because you're in a calculus class, but there's actually only maybe I guess if I probably like only 20% of what we do is really calculus. 80% is algebra still. You're welcome. What else? Yes, sir. Okay, yeah, let me clear this out and just open up a Word document. It'll work a little easier. Okay, square root of x. And you want to find the tangent line?